Hello class, so we're going to talk about color. So the first thing to know about color is that it's a property of light, not of the object itself. So it's through light that we see color. And the way this works is white light contains all the colors, and when it hits an object, for example, this red shirt is going to absorb all the colors except red, which reflects back to us in which we see. Okay, blue shorts are going to absorb all the colors except blue, and blue is going to be reflected back to us, and we're going to see that color. Okay, so objects have the ability to reflect certain colors of light and absorb others, and that's what creates the sensation of color. Now white reflects all light. So if something is white, that means it's reflecting all the light back at you. If it's black, that means it absorbs all light. The fact that color is a property of light is important, particularly for our next project, is because as the lighting changes, the color that we optically see will change. So grass is not going to look the same in the morning as it will in the afternoon, as it will at night. Okay, in the morning, it may appear to be if it's dewy outside, it might be a grayish green. Okay, a real subdued grayish green. In the middle of the day when the sun's out, it may be a yellowish green. At night, or not at, if you can see it at night with the moonlight, but I'm saying just closer to the evening, it may appear to be a bluish green. So the colors we see will change as the lighting changes. Now, there's something called a color constancy effect, and what that means for our perception is that although we see a different color, our brains tell us it's the same color. And it makes sense. Imagine if every day you went out and looked at your grass, and if it looked different, you would think it was a different lawn. Okay, or if you had a car and every day you went out, it looked different, or every time you looked at it, it looked a different color, then you get very confused. Okay, so even though we see different colors under different lighting conditions, our brain tells us it's the same color. All right, and there's two color mixing systems. The first is the additive system. So this is used with light. Okay, so stage lighting, all right, when lights of different colors are combined together, that's one way the additive system is used. Another one is LCD screens. Okay, different colored lights are combined to create our screens. All right, but we're interested in the subtractive system. Okay, the subtractive system is when pigments are mixed together. Okay, like painting and printing. And basically, when colors are mixed together, they work like filters. Okay, filtering out more light. Another aspect of color that is important is how a color looks depends on the colors around it. So you could change how a color is perceived by changing the colors around it. We rarely see a color just by itself. It's always in context and always next to other colors. This is very important. So let's look here. Do you see this little pink fuchsia rectangle? Okay, that's the same fuchsia rectangle. But just consider for a moment, how does it look different when it's surrounded by yellow than when it's surrounded by orange or this like rust color? Okay, I would say here it looks a little darker, here it looks a little lighter. That's one effect. Let's say here it looks to be a little warmer. Okay, but that might just be me. Alright, so let's look at this rust color against the blue. Which one do you think it looks brighter in? Let's say this one. It also looks a little orangier over here. It looks darker over here. Okay, let's look at this kind of, subdued green. How does it look different against this pale skin tone color and whatever color? I don't know what you would call this color, but this is grape color. How does it look different? Where does it look darker? I would say here. Where does it look brighter? I would say here. Okay, now let's look at this baby blue and how it looks different against the turquoise and this green. Hey, where do you think it looks brighter? I would say over here. I think it looks darker over here. Alright, so this is important to understand. Now we're going to talk about the color wheel. And the color wheel is one way of organizing colors. There's all types of different color organization systems. There's some that use charts. There's some that are in 3 dimensions that look like cylindrical. There's lots of different systems for organizing colors. Okay, but we're going to use the color wheel. It dates back to the 18th century. Okay, the primary colors are yellow, blue, and red. Okay, these colors can't be mixed. Okay, you have to start with them. Secondary colors, those are created when you mix primary colors. So if you mix blue and yellow, you get green. You mix yellow and red, you get orange. You mix blue and red, you get violet. Tertiary colors are when you mix a primary and a secondary color. So you mix green and yellow, yellow green, yellow orange, and so on, okay? We're talking about this in a little bit more detail. Okay? And this is important. Okay, so now we're going to talk about the 3 properties of color. And it's vitally important that you know this and remember this throughout the class. And I hope you remember it for life. It's hue. The 3 properties of color are hue, value, and saturation. Hue, value, saturation. Property number 1, hue. It refers to the name of the color as it appears on the outside of the color wheel. Okay, remember that. It's a way of organizing colors. And under our system, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's 12 hues on our color wheel. You know, it's possible if you wanted to break this up again, you could probably create 24. But on ours, we have 12. And there's, of course, there's hues in between, but we're looking right now in a simple way at 12. Now, every color that we see can be placed into one of these categories. So, for example, pink. Where's pink? You'd be like, okay, well, where's pink on the color wheel? I don't see pink on the color wheel. Well, pink has a hue of red. Okay, you get red, you get a little white, and you get pink. What about brown? Like, well, I don't see brown on the color wheel. Where's brown? Brown, it depends what type of brown. But brown generally has a hue of, red orange to yellow orange. Okay, so that is the hue. The hue could be red orange, or hue could be orange, yellow orange. Look at your skin. Everybody has different hues in their skin. But I'm looking at my skin right now, and I'd say it has a hue of yellow orange. So if you get yellow orange, you got a little white to it, and maybe a little bit of black, you would get my skin tone. Okay, and different people have different pigments in their skin, so there may be a little bit different recipe to create each of our skin tones. But nonetheless, all the colors that we see can be placed in our system of 12 hues. Okay, and you're like, how do you control hue? Like, okay, well, I want to get this certain hue. What do? Well, you could grab a paint tube with the desired hue. Let's say you want a certain color. You can mix 2 hues together. So let's say you want blue-green. Well, you could take a tube with the hue of green and a tube with the hue of blue, combine those together, and get blue-green. Okay, so anytime you want a certain color, you're going to want it to look to the right and left-hand side on the color wheel, and you can figure out what colors you need to mix. Now, except blue, red, and yellow, those are the colors that can't be mixed. Value. value is how light or dark something is. So a piece of paper is very light. The night sky is dark. Now, when you add white to a color, you're going to tint it, and that'll make it lighter. If you add black to the color, that's going to shade it, and that's going to make it darker. Okay, and of course, if you want to lighten something, you add white. You want to darken something, you add black. Or you could add a darker color. Now we're talking about saturation. Saturation is how bright or dull a color is. And sometimes students mix this up with value, okay, but they're different. Let's look at this little spectrum here. Okay, this blue right here is brighter, okay, has a higher saturation than this blue, okay? This blue right here is closer to gray. If it's closer to gray, it has a lower saturation. If it's brighter, then it's farther from gray. Let's think of red. A stop sign has red of a very high saturation. A faded red shirt that's been in the sun for a very long time is going to have a duller red to it. Alright, and if you want a lower intensity, then you could add gray, or you could add the complement, which is the color across from the original color on the color wheel. And what I'll do is let's go back to here. And so, for example, if you have red, you can add the complement, which is green, and that will lower the intensity. So if you have red, you can add green to it, and that will lower the saturation. If you had violet, you can add yellow to it, and that will lower the saturation. If you want to increase the saturation, you just have to go back to your original tube or tubes and add paint from there. Okay, but you're not going to be able to get a brighter saturation than what's coming out of the tube.